Hello friends, welcome to this wonderful video where I will be discussing 26 mathematics tricks, and these tricks will go a long way helping students in JAMB examination, American SAT, BESE examination, common entrance to beat time, especially in objective questions. So do stay and enjoy with me. The first question, which is I call trick 1, is just in various means through which you can multiply a number by 5 or 25, no matter the digits in that number, no matter the number you're talking about. So if I want to multiply 24 by 5, provided it is 5 that I'm multiplying with, just add 0 to that number and divide by 2. Add 0 to that number, divide by 2. 2 divided by 2 is 1, 4 divided by 2 is 2, and 0 divided by 2 is still 0. So the answer here is 120. That is for 5. But if it is by 25 that you want to multiply a number, just write a number, add double zeros to that number, then divide by 4. That is the trick for 25. Add double zeros, divide by 4. Now, if I divide 15 by 4, I will get 3, remainder 3. If I divide 30 by 4, I will get 7, remainder 2. If I divide 20 by 4, I will get 5. Therefore, when you multiply 15 by 25, you are getting 375. Let us go to trick number 2. Okay, for trick number 2, I call it multiplication by 99, 999, 9999. That is numbers that repeats 9. That is a very important trick of multiplying such numbers. For example, here, the first 9 here, we multiply the 3, it will give us 27. Just write 27, give a space. How many digits is left? Just a single 9. Place it at the center. The answer becomes 297. You come here again, take the first digit to multiply 4. 9 times 4 is 36. You write 36. How many 9s are left? 2 9s. You call it 99. 7 times this 9 will give us 63. You write 63. How many 9s are left? 3 9s. So you write 999. And this is the answer. That is how to multiply numbers that repeat 999999. Let us go to trick number 3. Okay, in the trick number 3, we want to get the square root of any 2-digit number without calculator. Whether it is perfect or not, you can get it without actually using calculator. These numbers are not perfect squares, so you can actually get their value without using calculator. That is trick number 3. But before you do that, you must know the square root of perfect squares. Maybe from the first 10 perfect squares. Let's see. The square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. It continues, but these are the basics. Okay, now, for me to find the square root of 34, I'll ask myself, among all these perfect squares we have here, 1, 4, 9, 16, 25, 36, and 49, which one is closest to 34 that we want to find the square root? The value that is closest to this 34 is 36, because 34 is very close to 36. 49 is very far from it. 25 try to be close, but the closest is 36. Therefore, I'll use the formula since 36 is closest, and you know that the square root of 36 is 6. So just use square root of 6 minus a over 2b. That's the formula. Once you find the value that is closest to it, the square root is 6, then say minus a over 2b. That's just the trick. What is a? A is the difference between the perfect square you are choosing and the number you want to get the square root, and that will give us 2, while b is the square root of that number you are using. You are using 36, and the square root of 36 is 6. Hence, to get the answer for this 34, the square root of 34 is going to be 6 minus a. My a is now 2 over 2 multiplied by b, which is 6. This will cancel out, so I have 6 minus 1 over 6. Okay, so what is 1 over 6? And 1 over 6, if you are familiar with recurring decimals, will give us around 1 point, it will give us 0.16666. That is what it repeats. Let's assume that this is 0.2, and 6 minus 0.2 will give us around 5.8 approximately. So the square root of 34 is roughly 5.8. This trick will give you an approximate value. Okay, for the let's clean and get for the second one. For the second one, which is square root of 20, before we can get it, check the value that is closest to 20. It is in between here. That is where you see 20 here, in between 16 and 25. But 20 is closer to 16 than to 25. Therefore, we are using 16. And the square root of 16 is 4. So we say 4. Instead of minus, we shall say plus a over 2b. The reason we are adding this time around is because we are using 16, which is smaller than the value 24. But when we were asked to get the square root of 34, we used 36, which is higher than 34. That is why we subtracted. But this time around, we are using 16, which is smaller than 24. Therefore, you have to add in order to increase the value. Now remember, a is always the difference between the value you are choosing and the square root you are using, which will give us 4, while my b is equal to the actual square root of the number I'm using, which is still 4. So it's gonna be 4 plus 4 over 4, 2 times 4, because b is 4, 2 times 4. 4 will cancel 4, leaving us with 4 plus 1 over 2. And 1 over 2 means 0.5, so we'll have 4 plus 0.5, which is 4.5. So actually, the square root of 20 is very close to 4.5. Let us go to trick number 4. So we are now in trick number 4. Trick number 4 implies the square of numbers ending with 5. So whenever you want to square any number that ends with 5, it is very simple. The digit is 5 here. Just square 5. 5 squared means 5 times 5, which is 25. You write 25. The 10th digit is 1. The next number higher than 1 is 2. Therefore, you call it 1 times 2, which will give us 2. Therefore, the answer is 225. For the second one, where you have 35 squared, just say 5 squared, it will still give you 25. The 10th digit is 3. After 3, the next higher number is 4. So just say 3 times 4. That will give us 12. So the answer is 1225. For this particular one, you just need to say 5 squared. 5 squared means 5 times 5, which is 25. You write 25. After 5, the next higher digit is 6. Hence, 5 times 6 will give us 30. The answer is 3025. As simple as that. Let us go to trick number 5. So we've now got to trick number 5, which I call unique way of adding numbers. So apart from the normal way you add numbers beginning from the unit to the hundred, you can actually add it in a different way. You can say 4 plus 7 is 11. You write 11. 5 plus 8 is 13. Give one space. You write 13. And 6 plus 9 is 15. Give one space. You write 15. Now let's add. This is 5. This is 4. This is 2. You bring down 1. This makes it easier for you to say 5 carry 1 and all that. It solves such problem of carrying. And you've seen that we've got actually the right answer without doing it the usual way. Let's go to trick number 6. Okay, we've gone into trick number 6, which I call the finger multiplication. You can actually multiply numbers ranging from 6 to 10 only using the finger multiplication. So get one of the fingers, label it 10, 9 down to 6. The other one will begin to 6 up to 10. So if I want to multiply 7 by 8, look at my 7 here. I will shade 7 down, 8. I will shade 8 down also. Now, how many fingers have I shaded? 1, 2, 3, 4, 5. I will write 5. How many are unshaded? This side I have 3. This side I have 2 unshaded. So this is just saying 3 here, multiply by 2 here, and 3 times 2 here will give us 6. Therefore, 7 times 8 is 56. Okay, for the second one, where we have 6 times 9, just change 6 down, which is only 6, times 9. I have to change 9 down. Now, how many fingers are shaded? Remember, we are talking about 6 times 9. How many are shaded? 1, 2, 3, 4, 5. You write 5. How many are unshaded here? 1, 2, 3, 4. You write 4. How many are unshaded here? 1. You write 1. Then 4 times 1 will still give us 4. Therefore, 6 times 9 is 54. Let's go for the last one. Okay, in the last question here, we have 6 times 6. 6 times 6, you shade 6 down, and you shade 6 down. How many fingers are shaded? 1, 2. You write 2. How many unshaded here? 1, 2, 3, 4. You write 4. How many are unshaded here? 1, 2, 3, 4. You write 4. Then 4 times 4 will give us 16. Don't come and write 16. Just write 6 and carry 1. If I carry that 1 and add to these 2 turns 3. Therefore, 6 times 6 is 36. We've now seen how useful the finger is in terms of multiplication. Let's go to the next trick. Okay, we are now in trick number 7, which I call multiplication trick. This trick is useful in multiplying any number of digits. But before you can use it, just draw a box, divide it by 2, horizontally and vertically. Then after that, try to slant it through the vertices. Like I'm doing, you slant it through the vertices. The first number is 23, so you write 2, 3. The next number is 34, you write 3, 4. Now, 2 times 3 will give us 6. But don't just write 6, call it 0, 6. 3 times 3 is 9. Don't just write 9, call it 0, 9. You come here, 2 times 4 is 8. You call it 0, 8. Why 3 times 4 is 12? 12 is 1, 2. Then add it diagonally. You add diagonally. So I'll add here. I'll bring down 2. 8 plus 1 plus 9 is 18. You write 8, carry 1. 1 plus 0 is 1, plus 6 plus 0 is still 7. You write 7. This is 0, you bring down 0. And of course, 0 is insignificant here. Therefore, you've seen that 23 times 34 will give us 782. Let's go to trick number 8. Here comes trick number 8. In the trick number 8, we call it multiplication by 11. But this one, we are talking about multiplication by 2-digit numbers, which are still meet 3-digit number. If you have 25, and you want to multiply it with 11, provided that it is 11 you want to multiply any number with, don't touch this 11, don't stress yourself. Just say 2 plus 5, it will give you 7. Write 7 at the answer. The answer is 275. As simple as that. So here, where you have 94, multiply by 11, don't touch 11, don't stress yourself. Just say 4 plus 9 is 13. But you don't just write 13, you write 3 and carry 1. Add that 1 to 9, 9 turns to 10. Remember, you have 3, 4 here. Therefore, 94 times 11 is 1034, and 25 times 11 is 275. Let's go to trick number 9. This time around, we want to multiply numbers by 22, 33, 44, 55. Any number that goes in this pattern is very simple to multiply, provided it is having the same digits, 2 digits that are same. That is trick number 9. Now 45 times 22, we can call it 45 times 11 times 2. That's the implication, because 11 times 2 gives us 22. Now let us concentrate on 45 times 11. And you have a trick of multiplying any number by 11. You just say, look at 45 that we want to multiply by 11. Just call it 4 plus 5 is 9. Write 9, it becomes 495. Then use 2 to multiply. 2 times 5 is 10, 0 carry 1. 2 times 8 is 18 plus 1 19, 9 carry 1. 2 times 4 is 8 plus 1 9. Therefore the answer is 990 without wasting time. Now for 33, if I want to multiply 38 by 33, I have known that 33 can be seen as 11 by 3. And to multiply 38 by 11, I will just add the digits. 3 plus 8 is 11. I'll write 1 carry 1. That 1 plus 3 will give me 4. So I'm having 418, then times this 3 here. So let me multiply. 3 times 8 is 24. You write 4 carry 2. 3 times 1 is 3 plus 2, 5. And 3 times 4 is 12. So this is the answer. If it is 444, you know what to do. So let's go to the next trick. Okay, we've gone into the trick number 10, which I call the butterfly method of adding or subtracting fractions. So where you have 2 over 3 plus 1 over 5, gone are the days you find LCM to simplify fractions like this. Just draw a butterfly. Let's write it 2 over 3 plus 1 over 5. Draw your butterfly like I'm doing. Is this not a butterfly? Now, just say 3 times 5 is 15. You write 15. 5 times 2 is 10. Plus 3 times 1 is 3. And 10 plus 3 will give us 13 all over 15 as the answer. So let's go for the second one. And the second one will have 4 over 5 minus 2 over 3. In the same manner, you draw the butterfly. So 5 times 3 is 15, you write 15. 3 times 4 is 12, minus 5 times 2 is 10. Remember, you must begin from this side. If not, you fail it for subtraction. And 12 minus 10 will give us a 2 all over 15, and that's the answer. We call it the butterfly method. Let's go to trick number 11. Okay, so this is trick number 11. Call it removing fractions from whole numbers. Provided that you have a proper fraction that you want to remove from whole number, for the first one, where you have 1 minus 2 over 3, provided that the number here is 1, don't stress yourself. Just call it 3 minus 2 is 1 all over 3. Finish, and that's the answer. For the second one, where you have 3 minus 4 over 7. Unfortunately, this 3 is not 1, but you can get 1 from it. You can call it 2 plus 1, because 2 plus 1 will give us our 3 back. Then you now say minus 4 over 7. So we've got 1 minus 4 over 7. Just call it 7 minus 4, which will give us 3 all over 7. Then you bring your 2 whole number and write. Therefore, the answer is 2 whole number 3 over 7. For the last one, where we'll have 8 minus 2 over 5. This can be seen as 7 plus 1 will still give us our 8. Then minus 2 over 5. Now we're having 1 minus 2 over 5. You say 5 minus 2 is 3 all over 5. Then you bring your 7. So your 7 whole number 3 over 5. As simple as that. Let us go to trick number 12. Okay, this is trick number 12. In trick number 12, we'll talk about how to get perfect squares without actually using a calculator. So for the square root of 64 for a child who doesn't know square root of 64 off heart, you can teach the child to draw lines. Right, 64, you start dividing by the smallest number that can divide, as if you're getting LCM. 2 here will give us 32. 2 again will have 16. 2 again will have 8. 2 again will have 4. 2 again will have 2. And 2 again will have 1. Once you see 1, we stop. Because it is square root means double. Square is double. That's why you have P square as a musician. So you have 2. If you get double, you call it 2. If you get double, you call it 2. Therefore, the square root of 64 will now be 2 times 2 times 2. 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. Hence, the square root of 64 is 8. Let us try the second one. And the second one, we want to get the square root of 900. As usual, draw your line. You write 900. 2 can divide. If I divide 900 by 2, I will get 450. If I divide by 2, I'll have 225. 3 can go. I'll have 75. 3 can go again. I'll have 25. 5 can go. I'll have 5. And 5 here will give me 1. Once I see 1, I stop. This is pairs of 2, pairs of 3, and pairs of 5. Hence, square root of 900 is the same thing as these 2 times the next 3 times 5. And 2 times 3 is 6. 6 times 5 is 30. Hence, the square root of 900 is 30. Let's go to the trick number 13. Okay, this time around we want to go into trick number 13, which I call perfect cubes. You can actually get perfect cubes without using calculator. Okay, now the first number we have here is cube root of 125. Just draw a line. You write 125. Divide by what can divide. The only number that can divide here is 5. 5 here is 25. 5 here is 5. And 5 here is 1. Once you see 1, you stop. Cube root means you group 3, 3. Unlike square root where you group 2, 2. So you group 3, 3 here. The answer is just 5. Hence, cube root of 125 is 5. Because 5 times 5 times 5 into 3 times, which is the cube, will give us 125. Let us try this one. We have cube root of 216. Just draw a line. You write 216. 2 can divide. 2 here will give us 108. 2 again will have 54. 2 again will have 27. 3 will have 9. 3 will have 3. And 3 will have 1. Cube root, if you get 3, you call it single. If you get 3, you call it single. 3, 3. So therefore, the cube root of 216 will give us 2 times 3. 2 times 3, which is 6. Unlike square root where you group 2, 2. Okay, so let's go to the trick number 14. We are now in trick number 14, which I call ordering of fractions. If you are given 2 fractions and you want to know the one that is greater than the other, you can use this trick I'm about to give out. Okay, just cross multiply. If you want to know 2 over 3 and 4 over 5, the one that is bigger, just cross multiply like this. 5 times 2 is 10. 10 is going for 2 over 3. 3 times 4 is 12. And 12 is going for 4 over 5. Since 12 is bigger than 10, it means that 4 over 5 is bigger than 2 over 3. Or 2 over 3 is less than 4 over 5. So this is less than. For this one, we'll have 8 over 10 and 4 over 5. You cross multiply. 5 times 4 is 40. 5 times 8 is 40. And 10 times 4 is still 40. So both of them are equal. Therefore, you put equal to. And the last one where you have 5 over 6 and 4 over 5. As usual, cross multiply. 5 times 5 is 25. And 6 times 4 is 24. 25 is bigger than 24. Therefore, 5 over 6 is bigger than 4 over 5. So I will put greater than. That is how you know a fraction that is bigger than the other. Let's go to trick number 15. Okay, in trick number 15, we call it divisibility by 3. If you want to know if a number is divisible by 3, add the digits that make up the number. After the addition, if the result is giving you something 3 can divide, it means that 3 can divide that number. For example, in number 1, I have 4 plus 2 plus 3. And 4 plus 2 is 6. 6 plus 3 will give me 9. Now you ask yourself, can 3 divide 9? Yes. Since 3 can divide this 9, it means that this number is divisible by 3. For this one, I will call it 1 plus 2 plus 3. 1 plus 2 is 3 and 3 plus 3 is 6. Can 3 divide 6? Yes. Since 3 can divide 6, it means that 3 can divide this number. For this one, I will call it 7 plus 2 plus 9. 7 plus 2 is 9, and 9 plus 9 is 18. Can 3 divide 18? Yes. Since 3 can divide 18, automatically 3 can divide 7 to 9. But if you have something like 4 to 5, for instance, let us call it number 4. Check if 3 can divide this number. You add 4 plus 2 plus 5. 4 plus 2 is 6, and 6 plus 5 is 11. 3 cannot divide 11. Therefore, this number here is not divisible by 3. Let us go to trick number 16. Alright, we've headed into trick number 16. In this trick, we want to multiply more than 2 digits number by 11. Now here is the trick. We have 154 to be multiplied by 11. Just bring down the first digit here, 4. 4 plus 5 is 9. Write 9. Say 5 plus 1 is 6. Write 6. Then bring down 1. You will see that when you multiply 154 by 11, you must get 1694. As simple as that. For this one, we'll have 1, 2, 4, 6 times 11. Just bring down the first digit, 6. 6 plus 4 is 10. Look at 10 here. Don't write 10 when it is more than up to 2 digits. Since 6 plus 4 is 10, write 0 and carry 1. Now 4 plus 2 is 6. Plus the 1 you carry 7. 2 plus 1 is 3. You write 3. Then bring down 1. You will see that when you multiply 1246 by 11, you will get 13,706. Let's go to trick number 17. Okay, in trick number 17, we want to convert repeating recurring decimals to fraction. This is very, very simple. Anytime you are given a decimal that is recurring and you want to convert it into a fraction, it's very simple. First of all, ask yourself, how many digits are repeating here? Just 3. This dot 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 means it continues, that it doesn't end here. Okay, if I like, I can just put one dot on top of 3 to show that 3 is repeating. 3, 3, 3, 3, 3. Therefore, this number is just 3 over 9. Just bring the digit that is repeating, divide it by 9. So 3 here is 1, 3 here is 3. The answer is 1 over 3. If it is one digit that is repeating, that is when you write 9. If 2 digits repeats, write 9, 9. If 3 digits repeats, write 9, 9, 9. If 4 digits repeat, write 9, 9, 9, 9, 9. So the number of digits that repeats will determine the number of 9 you are going to write. That's just the trick. That is the way it works. Here you have 0.2525. This dot dot means that 25, 25, 25 continues to repeat. So because 2 digits are repeating, you write the 25 that is repeating over 99. I'm using 99 because there are 2 digits that are repeating. Unlike where I use a single 9 where only 1 digit repeats. For the last one here, we have 0.152 dot 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 showing that 152 keeps on repeating. So 3 digits are repeating. You write it 152 over 999 because 3 digits are repeating. The 9 is going to be 3. When 4 digits repeats, the 9 is going to be 4. This is how to convert repeating recurring decimals to fractions. Let's take another question, which is trick number 18. We are heading to trick number 18, and in trick number 18 we want to find how to divide a number by 11 without using calculator. For the first one, we will have 6842 divided by 11. To divide this number by 11, just write down the first digit, which is 6. Then say 6, this 8 here minus 6 will give us 2. You write 2. 4 minus 2 here will give us 2. You write 2. And 2 minus 2 will give us 0. Neglect the first digit. Take the first 3 digits. Neglect the first digit. So the answer is 622. Remainder 0. This is the remainder. And the remainder 0 is nothing. Therefore, when you divide this by 11, you are getting 622. For the second one, we will have 49742 divided by 11. The first digit here is 4. You write 4. 9 minus 4 is 5, you write 5. 7 minus 5 is 2, you write 2. 4 minus 2 is 2, you write 2. And 2 minus 2 is 0, you write 0. Neglect the first digit, take this. So the answer is 4,522. The remainder is 0. The 0 is useless since the remainder 0 is nothing. So this is the answer when you divide by 11. In the third one, we'll have 6, 3, 5, 6 divided by 11. Please be more careful in this case. Bring down your 6. 3 minus 6, it cannot go. You borrow 1. This is now 13. This 6 will now reduce to 5. Now, 13 minus 5 will give us 8. Okay? Then, 5 minus 8, it cannot go. You borrow 1. This reduces to 7. You have 15. You now say 15 minus 7 is another 8. Now, 6 minus 8, it cannot go. You borrow 1. Here is 16. 8 reduces to 7. And 16 minus 7 will give us 9. So the answer is first 3 digits. So we have 577 whole number, 9 out of 11. There is remainder this time around. If you put this to decimal, you'll be getting around 577.8 approximately. So let's go to trick number 19. Alright, we are now in trick number 19. And we call it division by 9. You can actually divide any number by 9 without waste of time. So you have 2, 3, 1 divided by 9. Just bring down your 2. 2 plus 3 is 5. 5 plus 1 is 6. Neglect the last digit. Take the first 2 digits. So the answer is 25 whole number, 6 over 9, which you can reduce as 3. 3 divided 6 is 2. And 3 divided this is 3, which is 25, 2 over 3, or 25.666 when you change to decimal. For this one, where you have 403 divided by 9, you write 4. 4 plus 0 is 4, and 4 plus 3 is 7. Take the first 2 digits. So the answer is 44 whole number, remainder 7 all over 9. You can equally convert to decimal. Now for the last one, we will have 637 divided by 9. 637 divided by 9. The first digit here is 6. 6 plus 3 will give us 9. And 9 plus 7 will give us 16. The reason I'm demarcating in this case is that I'm getting 9, which is equal to what I'm using to divide. We don't tolerate it. Now, 16 minus 9 will give us 7. Okay? (16 minus 9 will give us 7, carry 1. Add that 1 to 10, add that 1 to 9, it becomes 10. You write 0, carry 1. Then that 1 plus 7, that 1 plus 6 will give us 7. Neglect this digit, so the answer is 70 whole number, 7 all over 9. You can equally convert to a decimal. So let's take the trick number 20. Okay, we are now in trick number 20, and we call it multiply consecutive odd or even numbers together. When you have consecutive even numbers, 6, 8, consecutive means that they're together. After 6, you get 8. After 10, you get 12 in terms of even numbers. For odd numbers, after 19, you get 21. Such numbers like 3 and 5, 7 and 9, 6 and 8, 10 and 12, etc. They are consecutive in terms of odd and even. But before you can get this trick well known, you must know the perfect squares. Okay? For example, 6 and 8, the number between them is just 7. And the 7 squared is, that 7 squared will give us 49. Then after squaring, remove 1 from it. The answer is 48. Now, 10 and 12, the number between them is 11. And 11 squared should be 121. Then after that, minus 1. 121 minus 1 will give us 120. For 19 and 21, the number between them is 20. Then 20 squared will give us 400. Minus 1, you will get 399, and that is the answer. For this trick to be useful to you, you must master the basic square numbers very well before you utilize it. Otherwise, the normal multiplication becomes better. Let's go to trick number 21. Okay, so this is trick number 21. I call it subtraction trick for numbers that looks as if they are reversal of each other, like 93 39 reversal, 65 56, 72 27. Whenever you see numbers like this, it's very simple to subtract them. Don't waste your time. Just say 9 minus 3 will give us 6. That 6 multiply it by 9, you get 54. This 9 is a constant. The 9 must be there. 9 minus 3 is 6. Then 6 times 9 will give us 54. Coming here, 6 minus 5 is 1. Multiply by 9. The 9 must be constant. You get 9. 7 minus 2 is 5. Multiply by 9. It will give you 45. That is how to subtract numbers like this. Let's go to trick number 22. Okay, in the trick number 22, we want to see this addition trick. Provided that the numbers are repeating the same digit, 1 1 1 1 or 2 2 2 2 or 3 3 3 3 3, it is simple to add them. So the highest digit here has 3, 1 2 3. Therefore the answer is 1 2 3. Don't stress yourself. The highest digit here is 1 2 3 4. So just write 1 2 3 4. As simple as that. If I were you in this one here that has 2, 2 is common, you can factor out 2. 2 divided 2 is 1. 22 divided 2 is 1 1. 2 2 2 divided 2 is 1 1 1. 2 2 2 2 2 2 divided 2 is 1 1 1 1. Okay. Now, and of course, you know that once it is having 1 1 1 1 1 everywhere, the last digit is 1 2 3 4. So you write 1 2 3 4. Then multiply by 2. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. So the answer is 2468. So let's go to trick number 23. Okay, in the trick number 23, we'll call it the square of two-digit numbers. I can actually get the square of 16 without using calculator. The first digit here is 1. I will say 1 squared, separate it. Then get 2. This 2 is a constant. Use the 2 to multiply the individual digits that make it up. So I have 2 times 1 times 6. Then the last digit is 6. Square it. 6 squared. Now 6 squared is 36. 6 times 1 is 6 times 2 is 12. 1 squared is still 1. Now to get your answer, you write 6, carry 3. Add 3 to 12, it becomes 15. You write 5, carry 1. Add 1 to 1, it becomes 2. Therefore, the square of 16 is 256. Let's go to 43. So 43 squared is the same thing as saying 4 squared. Separate it, get 2. Use it to multiply the individual digits. Then get 3, square it. 3 squared is 9. 2 times 4 is 8. 8 times 3 is 24. And 4 squared is 16. You write 9. 24, you write 4, carry 2. Add that 2 to 16, it becomes 18. Therefore, the square of 43 is 1849. And the last one here, where we have the square of 68. You just say 6 squared. Get 2, use it to multiply 6 and 8. Then you write 8 squared. 8 squared will give us 64. 2 times 6 is 12. 12 times 8 is 96. 6 squared will give us 36. Now bring down 4, carry 6. If I add 6 to 96, it becomes 102. I will write 2 and carry 10. If I add that 10 to 36, it becomes 46. Therefore, the square of 68 is 4624. Okay, in the trick number 24, I call it multiplication for kids. When you want to multiply 5 by 3 for a kid who is finding it so difficult to multiply, just draw 5 lines, 2, 3, 4, 5. Then draw 3 lines, 1, 2, 3. Check the points of intersection. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Therefore, 5 times 3 will give us 15. For this one, where we have 35 times 4, write 3, 1, 2, 3. Then give a space, draw 5, 1, 2, 3, 4, 5. 35. Then draw 4 horizontal lines. 1, 2, 3, 4. Check the points of intersection. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20, write 0, carry 2. Now let's check here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Plus the 2 we carried, it becomes 14. Therefore, 35 times 4 will give us 140. Let's go to trick number 25. In the trick number 25, we want to see the sine, cosine, and tangent trick. To get the sine, cosine, and tangent of special angle with our calculator, look at the trick we are going to make use of. So this is just the trick. Take for instance, if I'm talking about sine 30. Sine 30 is here, so which is 1. My sine 30 degrees will be, this is square root of 1 over 2. This 2 is for all of them. And square root of 1 is 1 all over 2, which will give me half, or 0.5. If I'm talking about cos 30 degrees, look at cosine below here. Cosine is 3 for cosine, and it's under root. I have root 3 all over these 2. This is the value of cos 30. Okay, now assuming I'm looking for sine 90. Sine 90 will now be, look at 90 here, 4, square root of 4 all over 2. And the square root of 4 is 2 all over 2, which will give me 1. Therefore, so sine 90 is 1. Now, if I want to get cos tan 30 tangent, look at what I will do here. I want you to understand that tan theta is equal to sine theta all over cos theta. Therefore, tan 30 will now be cos 30, which is 1 over 2, divided by cos theta, cos 30 also, which is root 3 over 2. Root 3 all over 2. This will now be 1 over 2. Changing division to times, I'll have 2 all over root 3. This will cancel out. My answer is now 1 over root 3. And so whenever you get sine theta and cos theta, you can use it to get tan theta, because tan theta is sine theta over cos theta. Let us go to the last trick. Okay, this is now the 26th trick, which is the last trick I have for you in this particular video. We call it powers of 11. We can actually get the powers of 11 without calculator following Pascal triangle. Now look at how to do it. Just write 1, cover it with 1 and 1. 1 plus 1 is 2, cover it with 1 and 1. 1 plus 2 is 3. 2 plus 1 is 3, cover it again with 1 and 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4, cover it again with 1 and 1. 1 plus 4 is 5. 4 plus 6 is 10. But when it gets to this stage whereby you're having more than one digit, begin from here, cover it with 1. 4 plus 1 is 5. 6 plus 4 is 10. Write 0, carry 1. 6 plus 4 is 10, plus the 1 you carried, 11. Write 1, carry 1. 4 plus 1 is 5, plus the 1 you carried, 6. Then cover it with 1. For 11 squared, this is where you are seeing 2. Therefore, 11 squared is 121. The 11 power of 3, this is where you see 3 first. Therefore, 11 power of 3 will give you 1331. 11 power of 4, this is where I'm seeing 4. So 11 power of 4 will give me this, 14641. Then this is 11 power of 5, and it continues like that. So here comes to the expiration of this my 26 powerful mathematics trick. Expect more tricks in the subsequent video. Thank you so much for viewing, and may God bless you. Don't forget to subscribe to my YouTube channel. Follow me on Facebook, Instagram, TikTok. My name is Esomnofo Online Maths. Let us join hands together and kill maths phobia. Thank you so much.